Today I will teach gradient. It is an important chapter for vector calculus. So to understand the gradient, first of all we have to know the vector differential operator, that is del. It is also called nabla. Del is equals to del del x of I plus del del y of j plus del del z of k, where I, j, k is a vector quantity. It is very useful in defining three quantities which arise in practical application and which are known as gradient, divergence and curl. In this video, we only concentrate the gradient. Always we do gradient for any scalar, but we get after gradient a vector quantity. So let's take a scalar phi, which is a function of x, y and z. Phi x, y, z we defined and differentiable at each point of x, y, z in Cartesian coordinate system. Then grad phi, that means del phi, we can also write grad phi. Del phi or grad phi is defined as, just put the value of del. We know that the value of del is del del x of I plus del del y of j plus del del z of k, and phi is a scalar quantity, so the final expression is del phi del x I plus del phi del y j plus del phi del z k. So this is actually vector quantity. Phi is a scalar quantity. After doing a gradient, we get a vector quantity because this expression contain I, j, k. Now to understand clearly, we take an example. If phi xyz is equals to 3x square y minus y cube z square, then find grad phi at the point 1 minus 2 minus 1. So how we solve this problem? First, del phi, that you already get the expression. So put the values of del del x of I plus del del y of j plus del del z of k, and put the values of phi also. The values of phi is 3x square y minus y cube z square. Now, according to this formula, we can write del del x of 3x square y minus y cube z square, and this I, just write this I here. Then j del del y of 3x square y minus y cube z square plus k del del z of 3x square y minus y cube z square. Now we have to differentiate this term with respect to x, then y, then z. First, when we differentiate phi with respect to x, all other terms are constant. So first term I, when differentiate 3x square y with respect to x, then y is a constant. That means 3y is a constant. Differentiate only x square with respect to x, that is 2x. But when we differentiate y cube z square, that is equals to 0, because we differentiate with respect to x, but it is term with y and z, so this term is equals to 0 plus. Second term, again differentiate this with respect to y. Both this term contain y. So if we differentiate first term with respect to y, 3x square is constant. We differentiate y with respect to y, so dy by dy is equals to 1 minus differentiate y cube, that is 3 y square. Differentiate y cube with respect to y, that is 3y square. Z square is a constant here. Plus k. Differentiate this term with respect to z. But first term, there is a no z value. So this term is equals to 0 after differentiating with respect to z. But second term contains z value. So minus y cube is a constant. If we differentiate z squared with respect to z, then obviously 2z. So we can rewrite this line 6xyi plus second term is 3x square minus 3y square z square j, here plus and minus minus, so 2y cube z k. This could be an answer if the question is only find the gradient, but in this question here find the gradient at point 1 minus 2 minus 1. So we have to put x equals to 1, y equals to minus 2, z equals to minus 1. Actually this is the value of x, y, z. So the put x equals to 1, y equals to minus 2 and z equals to minus 1 in this equation. So just put it 6, x value of x is 1, y is minus 2, I remain same, 3 value of x is 1, minus 3 minus 2 third square because y square, so minus 2 square, z square, so minus 1 third square, j minus 2 y cube, that means 2 minus 2 third cube, z, the value of z is minus 1 and that is k. So the final answer is 6 multiplied 2, so minus 12i plus here 3 minus, here 3 minus 3 minus 2, that means 4, 12, so minus 12, j minus, again minus minus plus, so minus 2 to 8, 16, 16k. So final answer is minus 12y minus 9j minus 16k. So that is very easy. So in this way you can solve any equation, any question, any problem using this formula gradient. Thank you.